Today, we're going to go on a little journey. We're starting with something we do in the kitchen without a second thought, and ending with a skill that requires absolute life or death perfection. We're going to uncover the hidden and, frankly, pretty powerful connection between a simple recipe and a critical medical formula.
So baking a cake, or saving a life, it sounds a little dramatic, I know. But what if I told you that the exact same math that helps you bake a perfect cake is also being used by a nurse right now to save a patient's life? The thinking is identical. The stakes, though, well, they couldn't be more different.
And this really breaks it all down. On the left, you've got a simple baking ratio. 2 cups of flour for every 1 cup of sugar. If you get it a little wrong, okay, your cake is a bit dry, no big deal. But on the right, a medical dosage. 5 milligrams of medication for every 1 kilogram of body weight. You get that wrong, and the consequences are, well, incredibly serious. But look at them. They're both just comparing 2 things. They're both ratios.
So let's start in a familiar place, because here's the thing. You are already an expert at this kind of math. You really are, even if you don't call it that.
I mean, think about it for a second. When you decide to double a recipe because you've got friends coming over, that's proportional math. When you figure out how much gas you need for a road trip based on your car's MPG, guess what? That's proportional math too. You're doing it intuitively. You just know that if you have more people, you're going to need more ingredients. It's second nature.
So here's the key. The tool we're all using here is called a proportion, and all it is, really, is a simple statement that 2 ratios are equal. And this brilliant little tool lets us find a missing piece of the puzzle. Like with a map, right? If you know that 1 inch on the map equals 100 miles in the real world, you can set up a proportion to figure out how far 3 inches is. You just solve for x, and boom, you know your trip is 300 miles long. It's simple, it's powerful, and it's something you use all the time.
Okay, so let's take that same exact logic, that same tool, and walk out of the kitchen and straight into the clinic. Because this is where the context changes everything. This is the world that healthcare professionals live in, every single day. The same logic you use to scale up a cookie recipe, they apply that to the human body. And in that environment, precision isn't just a nice to have, it's an absolute requirement. And the stakes just couldn't be higher. We're not just talking about one task. It's calculating the perfect dose of a powerful drug, or reconstituting a medicine from powder, or figuring out the exact flow rate for an IV drip. And it becomes especially critical, so critical, when you're dealing with kids, where the smallest error can have a massive, massive impact. So let's make this real. How does a nurse actually calculate a dose for a child? It is a perfect, real-world example of this proportional math in action, where every single decimal point matters. Okay, so let's walk through it. First, the child's weight in pounds is converted to kilograms. Then, the nurse uses the ratio that the doctor ordered, 0.5 milligram of medicine for every 1 kilogram of body weight. They set up that proportion, they solve for the unknown, and they get exactly 4.55 milligrams. Not 4.5, not 5, precisely 4.55. And hey, if you need any more proof of how serious this precision is, get this. The Joint Commission, a huge healthcare accreditation group, actually forbids doctors from writing a trailing 0. Why? Because if you scribble 1.0, someone in a hurry could easily misread it as 10, and that's a 10-fold overdose. So the rule is, you just write 1. It's an incredible reminder that in this world, there is absolutely zero room for confusion. Okay, so this brings us to a really fascinating question. If the math is literally the same, why does it feel so different? Why is it so easy to double a recipe, but for so many people it's so stressful to calculate a dose? And that's the real puzzle here, isn't it? It's not just about the high stakes, though that's part of it. Research into how we adults learn suggests that there's something deeper going on. Something about the very idea of a fraction itself. Yeah, it turns out that a fraction isn't just one single idea in our brains. Researchers call them subconstructs, but I think it's easier to think of them as having different personalities. And depending on which personality of a fraction we're dealing with, the difficulty can just skyrocket. So the first personality, the most basic one, is part whole. This is the one we all know. It's a pizza. 2/3 just means 2 out of 3 slices. But there is a non-negotiable rule here. The slices must be equal. If the parts aren't equal, it's not a real fraction. This is usually the first way we ever learn about them, and it's the one we're most comfortable with. Now,
let's look at a tougher one, the measure personality. This way of thinking sees a fraction not as a slice of pizza, but as a super specific point on a number line, like a ruler. It's a precise distance from zero, like 3/4 of an inch. Now, this requires a much more abstract way of thinking, and for a lot of us, it's a huge mental leap from just grabbing a slice of pizza.
And the difference in our understanding is, well, it's staggering. In one study with adult learners, 29 out of 30 people got the part-whole question right. Easy peasy. But when they were asked to use that measure concept to place a fraction on a number line, only 3 out of 30 got it right. 3! It's the same numbers, the same math, but it requires a totally different kind of understanding.
So how do we bridge this gap, right? How do we connect that easy, intuitive kitchen math with the formal, high-stakes math you need in the clinic? Well, the answer lies in one single, incredibly powerful skill.
See, true mastery here isn't about just memorizing a bunch of formulas for every different situation. No, it's about developing something called proportional reasoning, and that is the master key that unlocks all of it.
Take a look at this. On the left, a student is figuring out the fat content in cheese. On the right, a nurse is calculating a drug dosage. I know, they look completely different, but their brain is doing the same thing. They are both asking the same fundamental question. If I know the relationship between these two things, how can I find the relationship in this other amount? That question, that is the heart of proportional reasoning.
So, proportional reasoning is basically the ability to see and use these relationships everywhere you look. And it's not just some concept you learn in elementary school and then forget about. No, it's the actual foundation for algebra. And as we've just seen, it's a truly critical skill for navigating life safely and confidently.
So that math you use to double a recipe, it's not dumbed down math. It is the same powerful fundamental logic that when you apply it with extreme precision becomes a tool for saving lives. This isn't just school math. It's a core competency for life. And that really brings us to a final thought. This one mathematical idea serves as both a simple tool for everyday convenience and, at the same time, a literal lifeline in a crisis. And it just makes you wonder, what other fundamental skills are we using every single day, completely unaware of their hidden and absolutely critical power?